this. Okay, I'm gonna start the recording. Okay. And so last week I was not successful in giving out a SIP 2025 t-shirt or a $15 Amazon gift certificate. And today I actually, well, and my computer is like still busted. But I talked to my finance person at work and I have like so much money. I don't know what to do with for work. And so Emma, you need to like find somebody who can come and like work with me. Because I have a lot of like grant money I need to spend in the next 12 months. Okay. So let's see if this week's geography quiz is gonna be easier. Actually, I think this is actually very, very hard. Okay. So if you're an SL, you can like try your hand on this too. Okay, I'm gonna give you guys 30 seconds to look at it. We're looking for the name of this place and we're looking for the country. Okay. So here's a picture. We're looking for the name of this place and the country. And I've learned from like my prior mistakes. Okay. I have like no answers on any slides. Okay. Name of this place and the country. Um, I mean, honestly, I would be kind of surprised if actually somebody got this, unless you've actually been there. Okay, there's more people joining. Let's see if the folks that's joining know the name of this place and the country. Uh, Hint. Okay. I'll give you guys a hint. It is somewhere in Europe. Okay. There are still folks joining, and so I'll give them like oh, one thing I wanted to highlight, I forgot to mention. Okay, Emma is graciously holding office hours tomorrow. And so, um, if you guys can want to go to office hours, you can go to office hours tomorrow. And then I also like have this Google form up on the forum. Um, if you guys want like a email reminder every week when these things are happening, you can fill out your email. I won't sell your email or private information to anyone, um, for money. Um, so go to Emma's office hours tomorrow. The link is in the forum. Um, Otherwise, Emma will feel very sad. She has to get up very early to hold office hours. Okay. And then next session is Friday, return of Alex. And so definitely come to Alex's session because he likes a full house and he needs lots of, like, no encouragement. Okay. So, anyways, okay. So I don't see any right answer. There's one person that actually said the right answer, but I think he saw the answer on my slide. It's actually Nick. Okay, so okay, I would have taken either this castle or this cave because this is actually a castle that's built on top of a cave and it's like the biggest karst cave in Europe. It's located in Slovenia. I just think it looks kind of like Helm's Deep in Lord of the Rings. And then if you ever visit, they have like an underground post office. You can send postcards to yourself. And there is a species of salamander that's albino, that's blind. You can only find in this particular cave. And then apparently this salamander is nicknamed the baby dragon. It's called the Ohms. They can live for up to 100 years or so, and they can go several years without food. Um, So, anyways, yeah, um, that's it for my announcements. I will let Chris take over, and then we can try again next Friday when Alex is back with another very hard place. Yeah.
Cool. Thanks, Vicky. Yeah, today we'll just be doing kind of a hands-on project that kind of aggregates everything that we've learned in the last couple data sessions. Vicky, I'm not sure if you shared the zip file with the class, but if not, I can share it now. I can upload it to Drive or something. Did you share it, Vicky? Or
Yes, I did. I did. I don't know if everybody downloaded it or not. I could put the link here for people.
yeah, if you
So
haven't
if you
uploaded somewhere.
haven't um, uh, downloaded it, you can download it now. Okay, let me just put that link real quick. Sorry. Let me find the link. Where is the link?
Oh boy.
Uh, let me find the link. Okay. Whoops. Okay. So I put the link in there.
All right. So I'll give everyone maybe like a minute to download it and unzip it.
Do you want them to open it in Jupyter Notebook or in
Yes.
like VS Code?
Um, if everyone can open it in Jupyter Notebook or something similar like Colab.
Do you think you could just demo how to uh open it again? I mean, I was able
Yeah.
to do it, but I'm not sure if people remember how.
Yeah. So let me share my terminal, or I'll create a new terminal. Um, it's like, Give me one sec. Sorry. Okay. So let me share my terminal here. So I opened up a terminal, and for those of you who are on Mac OS, reminder you can do this by hitting Command Space and then typing in terminal. Um, so once you have that open, you can just type Jupyter Notebook, and it should launch. It should say all of these. It should give you all this text, and then it should open a page on your default browser that looks like this. Um, where is it? Here. Is it visible? Here. Um, so you can navigate to the specific directory that your project download is in. So for me, that's in downloads. So I would click that, and then it would bring us to um, this project. Um, so this is what the notebook should look like. So I believe that's how to do it for Mac OS and Linux as well.
Linux.
Um, yeah, and then for Windows, yeah, sorry, I can't demo it directly, but I believe how we opened it before was using Anaconda Navigator. So if you can find that application from your like start menu, open it, and then you should be able to launch a Jupyter Notebook instance from that. So I'll give everyone a couple minutes to get that downloaded, unzipped, and opened in Jupyter Notebook. And then we should be on this page that I'm sharing right now once you have all that done. All right, by now, I'm hoping most people are on the same page as me. If not, feel free to send a message in chat, and I think maybe a section leader can get to you for help. But basically, this is just like a predefined Jupyter notebook that someone wrote, which is like a good resource to kind of learn a lot of the introductory topics that use like pandas and matplotlib and numpy. So we're going to kind of put everything together and work on this project together. It's kind of like a fill in the blank type project. So it will walk you through kind of the steps that we want to do. And then it's our job to fill it in and accomplish kind of like the tasks that each of the parts are detailing. And then basically the whole idea is that we want to do some analysis on certain stocks. You can see in the description here, we're just analyzing stock data for car companies from January 2012 to January 2017. And this is a good way to practice using all of these matplotlib, pandas, and numpy, which we covered in the past couple of sessions, and just like putting it all together and seeing how we can actually use that instead of just walking through like the functionalities of it. So as usual, we're going to start off by importing the libraries. This is also just going to flag whether or not you have it. If you were following along in the other sessions, then you should have these installed already. But if not, then you can install it on your terminal using either pip install or conda install. If you're having trouble figuring out the command, just drop a message in the chat, and I think someone will get to you. But yeah, everyone, please run that first cell just to import. Make sure you have all the required libraries, and then we can go ahead and get started on the next following parts. So first one is to actually retrieve the data. So we wouldn't be able to do any analysis without the data. So we're going to want to obtain like the stock information for the three stocks that we'll be analyzing today. So Tesla, Ford, and General Motors. There should, if you check your download directory for the project, there should be a CSV file or three CSV files included in them. So we're going to use pd.read CSV to read that into a pandas data frame, which is one of the three main pandas structures that we worked with last session. To illustrate like some of the tricks that we've covered, like way in the past for Jupyter Notebook, we can use tab to autocomplete. And when we want to understand like how we can use a specific method, one, obviously a good way is to just Google it. There's documentation online, but you can also hit Shift and then Tab, and it should open the doc string, which describes how you can use this function. This is actually pretty complicated because there's so many different arguments that we can use in the function. But most of the time, we don't actually need to use that many of them. There's just a lot of different ways that you can use it. But the most important one here, actually, sometimes their description will have like an example use case. Um, but to help you out a little bit, the most important thing here is the file path or buffer parameter, which is just a string that describes the string path. It can be a URL or it can be like a local path to a CSV file, which is what we have, and that's this first argument file path. Um, yeah, and let's see if they have any examples. I'm not sure if they will. Yeah, it looks like in this case they do. They have pd.readcsv data.csv. So that's kind of example usage. And then this should return like a data frame. And you can see that the return, it says here, it returns a data frame type. So now we can say like, we'll do /Tesla stock. The dot indicates like we're looking within our current directory. So this is kind of just like a shorthand notation for like relative file path. If you want, you could also type in your entire file path, which would be something like, I actually don't know, but like maybe like user, like my username, and then like downloads and something like that. But to avoid typing all that, we can just say dot. And then another handy trick, if you're interested, is like dot dot means the directory above. Um, so that's just something to note. But we can use /Tesla stock to read from the current directory, the Tesla stock.csv file that we have. And then another thing we can do is also name the index column. So we can call this date.
For the politics, that'd be.
So we can run that, and then when we call Tesla stock.head, head actually gives us the first couple rows of the data frame. So yeah, you can see here, return the first n rows. If we just did Tesla stock, then it would show like way more, which sometimes can just be overwhelming. If we want to just see like the shape of the data frame, we can just say .head. So this tells us like, this is what the first couple rows of our Tesla stock data frame looks like. You can see that the index column course we named date. So this is called date. And these are like our indexes. And then we also have 5 columns that correspond to like a bunch of different attributes of the stock on that particular day. So yeah, we can also look at what an index column is described as here. So you can see it's a parameter used in read CSV. And then here we can see it says columns to use as row labels, denoted either by column labels or column indices. So this is just like a label for our index. Yeah, and then we're going to do the same thing with our Ford stock and our GM stock. So if you want to try that for yourselves, feel free to go ahead of me. But I'm just going to type out essentially the same thing for each of these. So
Hey
we're going to have,
Chris, there's a couple questions. One question somebody asked is how do you pull up that tooltips?
the tooltip, Shift tab.
Shift tab? Where
Yeah.
do you click the shift tab?
So I'm not sure about how strict it is. If you just like kind of, I know if your cursor is next to the parentheses, it should work. Or if your cursor is on the function like read CSV, you can click anywhere on it. If you hit Shift Tab, it should give you that tooltip.
Oh, I'm doing that on a Mac and then it's not bringing up anything.
It's not bringing up anything. Were you able to run um, the cell
Yes.
and it didn't show any errors?
No.
Are you able to, if you just type, like say type PD dot and then hit tab, does anything show up? Like, do you
Oh,
see this list of,
hold on. PD dot tab.
Yeah, and then hit tab.
No, nothing shows up.
Nothing's showing up.
I don't show. I don't see that.
Um, that's interesting. I'm not sure if it's like related to specific like versions of Jupyter maybe, or just um like it's a one-off, like maybe uh like the data is not loaded into your Jupyter. I'm not actually sure how it gets populated. If you want to try restarting your kernel, like going to your terminal, killing the Jupyter notebook, and then
Okay.
trying to reopen it, that might work. But if not, then
Okay.
honestly, this is just like a handy tool to look it up within the Jupyter notebook. You can also just look up like pandas read CSV. Um, and then there's like almost always like the first result is like the actual official pandas documentation. It shows like essentially the same thing, um, like the same unreadable jargon of several arguments, but it has like the same description. Like here we see file path or buffer is the same, like any valid string path is acceptable, same with index call. It's the same documentation. It's just uploaded to like a web page.
Okay.
So
And then if you look at the Jupyter cell, next to it, there's like this bracket with a number. What does that mean?
I believe that's just the like numbered cell of like uh, which number cell you've run. So like this is 2 right now. The most recent one I ran was 5. If I run like this again, then it'll be 6.
Oh,
It's just
okay.
like a counter for how many cells you've run.
Got it. Okay.
Yeah. So I'm going to continue typing out the code for this. Feel free to continue asking questions. But hopefully this all makes sense so far. We're just going to do the same thing with all of the data that we have. So these are all CSV files that we already have downloaded in our directory. So I'm going to run these 4 cells, and then we can see what these data frames that we've created look like. And hopefully yours looks identical, actually. This should be pretty deterministic. So yeah, that's the first step, which is just loading in the data. So we did a lot of discussion last session about like, I guess, what a data frame is. So this here we're actually going to be able to see how we can use a data frame and like with actual data, I guess. So this time we have a Tesla stock CSV or a General Motors CSV with a bunch of like numbers, essentially like a Excel spreadsheet. And this read CSV function conveniently converts that data into a pandas data frame. And we'll use a lot of like the functions that we learned previously to manipulate the data and help us analyze these stocks. So a great way to analyze stocks is to visualize the data. So the second part is walking through how we can visualize the data. So some of this is filled out already. We have our first line, which just defines like a figure. And the figure size just tells us like kind of the dimensions of the figure. So we're going to have like a 12 by 6. You can think of it as just like some arbitrary like measurement form. So it's going to look like essentially like a 2-to-1 ratio, but 12 to 6 is kind of like just a set width or height for our figure. And then we're adding a title, which labels our plot as open, because here it says we want to create a linear plot of all the stock's open price. So yeah, we're just going to fill that out. So I'll just type it out here. I can't imagine any of you remember the syntax for matplotlib's plotting, but it should be pretty straightforward once you see it once. So here we're going to use our Tesla stock data frame that we defined earlier from the file, and we're going to access the open column. So actually, if we want to create a new, or just to show you, I'm going to create a new cell, and I'm just going to show you what this looks like. So if we select the open column under Tesla stock, this is what it looks like. So this is a series, which is like kind of a one-dimensional, the one-dimensional version of a data frame, if you remember that from the last session. But here you can see we've selected only the opening price of the Tesla stock. So we have all the dates from 2012 to 2017, and then only one value for each of those dates, which corresponds to the open value because we've selected the open column. So you can kind of think of it as like we're selecting like the values just in this column, and then that's what gives us this like this panda series. So this is pretty simple, or like this is a pretty clear definition of like I guess like a two-dimensional series of points. So we can imagine it like just plotting these values like individually, and it should create something that might make sense to us visually. So I'm going to delete this cell, and then I'll show you how we can plot it. So we basically just call plot, and then we label it equal to Tesla, and that should plot the Tesla chart for us. So you can kind of like seeing what the open column or the open panda series looked like. You can see how like each of these points, I guess they're connected by lines, but like each of these values were plotted on the graph. We have our index, which corresponds to date, and then we have our opening price, which corresponds to the y-axis. So yeah, you can see how like our series of points maps to this graph. So this is just the Tesla opening price. We'll do the same thing for Ford and GM. And then GM is going to be in top. So now when we run this, they'll actually be overlaid on the same graph. And you can see that there's a legend that tells us which color corresponds to which stock. So this is how we can visualize the stocks for the opening price for each of these three stocks that we're looking at. So that's kind of just like a cool way to represent your data in a visual way. So the next step is to plot the volume of stock traded each day. So if you go back to our data frame head, you can see that there's another column for volume. So as you can imagine, we'll probably do something similar with that we did with the opening price to plot the volume. So try to work through that. I'm going to type it out, but if you want to go back to your Jupyter tab and work it out yourself, feel free to. But also, no worries if you want to just watch me type it. And then we'll have Ford. And then we have GM. We can run that, and we see a graph that looks like this. So the last, I guess, portion for, I guess, actually, there's a couple more world traded. But yeah, I guess the last, for now, graph that we're creating, we can look at this one. Actually, before we go to this, does anyone have any questions? Let's see the chat. Looks like we're good. So if there are no questions, then we'll move on to this one. This is kind of like a bonus question that they have in the project. Basically, we can use specific like pandas functions to help us identify certain things. So you can see like Ford had a really big spike in late 2013. So that would be this, which would have been hard for us to find had we not graphed the data. So now we want to find like what is this specific date that this max volume of trading happened on, somewhere between like 2013 August to 2014 May. So here we can use something called the argmax function. The comment below kind of gives us a hint of what day we're expecting, but we can see if we can get to that answer using argmax. So first we want to figure out, I guess, what is argmax. So we can use that handy shift tab to pull up the tooltip to describe to us what argmax is. So here it says returns the integer position of the largest value in the series. So an example would be if we have this series, cornflakes is equal to 100, almond delight 110, cinnamon toast crunch 120, and cocoa puff 110. We can see that the max value is 120, but we want the function to tell us where that maximum value occurred. So we want it to tell us essentially where cinnamon toast crunch is, and you can see that it returns 2, which corresponds to the index 2. So this gives us like a numerical location for where that maximum occurred. So how to use it is just we take the series or we take the data frame and we call argmax on it. Or we take the so we can find the series. So we can pull looking at trading volume. So we can say Ford stock volume, and this should give us a series. And then if we call argmax on it, it should give us a number. So this is the index where the maximum trading volume occurred for Ford. But this number isn't that useful to us because it doesn't tell us what day it is. So what we can do is actually define, like let's set this value equal to an index. So we can actually do it maybe in the same cell. So we'll say like Ford max volume index is equal to Ford stock volume dot argmax. And then if anyone recalls, we had something called iLoc, which is short for, I believe, index location. Purely integer location-based indexing. So if you remember, data frames have integer-based indexes and also, I guess, like whatever the type defined as an index is. So like the index doesn't have to be a number, but there's always a way to query it based off of a number using iLoc. So using loc without an I would allow us to pull from specific specific index types. So like in this case, it's the date. But since here argmax just gives us the actual numerical index, we're going to use iLoc, and then we're just going to pull Ford max volume index. So remember, this was like 493. So now when we call iLoc Ford stock.iLoc and access the 493rd index, it should give us the row that corresponds to that index. So you can actually see that the index name is 2013, 12, 18. So December 2013, and then you can actually see all of the values corresponding to each of the columns. And then you can see that this matches with the date that we have here. And then if you're curious, we can visit this URL to see this URL is not valid anymore. But I'm sure you can do some research and figure out what happened on that day. But yeah, that's a cool way to, if you're curious, like if you notice on the graph there's like a spike, this is how you can find out where that spike occurred. So kind of like taking the visualization of the data and then extrapolating information from that visualization. So yeah, this is just like a common, I guess, like statistical analysis kind of thing where you're just like looking at the data and seeing what information you can get from it. But yeah, any questions with that? Yeah, the date serves as the index for this data frame, correct. And we can see that again here. I guess it's like not explicitly denoted, but you can see that all of these dates are bolded. And that just is an indicator that this is like the index for the data frame. And because we read it in as index column equals date, date is what we're calling our index column. But it's also just the index. So yeah, the next step, this tells us, the information that we've been plotting is not like cannot be completely taken at face value. So we want to look at like the total market cap, not just the stock price. So essentially, what we want to do is represent the total money traded. So we can do that by multiplying the volume column by the open price column. But it's, yeah, so not that market cap, but a visual representation of how much money is being traded around. So here we're actually going to be modifying the data frame. So this first step asks us to create a new column called total traded, which we'll create by just multiplying the open price by the volume traded. So what this will look like, Tesla stock is our data frame, and we can actually add a new column by doing something similar to like a dictionary insert, where we're describing this is the column name and then what we're assigning the column to. And then if you remember from NumPy, we can just directly do the multiplication. So we have Tesla stock open, which is a series similar to like a NumPy array. And then when we multiply Tesla stock volume, this kind of gives us like, it multiplies each corresponding row by each other. So we can do this, and then we can look at Tesla stock.head again, and we'll see this is what it looks like. So you can see that this number was generated by multiplying within this row open times volume, but this syntax tells the data frame to multiply all the values in the open series by all the values in the volume series by like their individual like row index. So this just creates like a whole new series where each value corresponds to that index's open times volume. So that's how we generate this new column. And now we have a new column in Tesla stock called total traded. And then let's do the same thing with Ford and GM. Stock. And then if you want to take a look at the outputs, you can just look at what all of these look like. I would recommend just checking each of the heads to make sure that that column got added. You can also just do that in a new cell, so you don't have to rerun the arithmetic. Yeah. So we can see that we've added this column to all of the data frames that we have. So now we want to plot the total traded against the time index. So again, I'll just type it out, but I would recommend trying this for yourself. We've done something similar with like the open and the volume plots, so it should look pretty similar to that. So here's what my graph looks like. Take a look to see if yours looks similar. And now we have another observation from the total traded graph that we've plotted. It looks like there's a huge amount of money traded for Tesla somewhere in early 2014, this big spike. What date was that and what happened? So here we can do a similar analysis. So let's try doing what we did before. So we can have something like Tesla max volume index, Tesla stock volume argmax, and let's say Tesla stock dot. And let's see what this gives us. So you can see here, oh, actually, sorry, we're not looking at volume. Total traded. Yeah. And this gives us 2014, February 25th. And then there's another article. I would imagine this also does not lead to a valid URL, but you can imagine, this tells us something happened on that day. So this is how we can figure out when that happened. Yeah. So that was pretty similar to what we did for the existing open and volume columns. But here, the main takeaway is that we added a column and now we're working with it. So some columns are like results of existing columns. That's part of like one of the data manipulation tactics that you can do with data frames. And we're actually able to identify some event that happened with Tesla using this new column total traded that we created. Yeah, the next step, this isn't something that we exactly talked about, but this was just included in the project already, and we can just, so I left this in, but we can kind of just like look at the graph here. If you're curious, essentially like the moving average is essentially like an average across like a certain window from like that point in the past like X number of days. So window is going to be like, if window is 50, then we have like the last 50 days or 50 indices to calculate the mean for it, and that gives us the value that we're plotting against the y-axis, and then the x-axis is just the date. So moving average 50 is 50 days, and then that's the blue one, and then MA 200 is the orange one. So you can see that it doesn't start until 200 days in, roughly, because before that, there's no like 200-day window that we can even calculate. So this kind of just gives us like a more, I guess, like roughly approximated version of the graph. You can see they kind of follow a similar like trajectory, but the MA50 is a little more granular, and then even the regular graph that we have up here is way more granular. So if you're curious, that's moving averages. It was included in the project. I didn't want to take it out in case people were curious, but don't expect to have known this before. But yeah, this is just one of the things that we did. So yeah, moving on. Let's see if there's a relationship between the stocks, as they're all related to the car industry. So here's something called a scatter matrix plot. So here we're actually just importing scatter matrix. This is a function that exists in pandas plotting. So if we do scatter matrix, let's see if we have a docstring. Docstring is pretty simple. It just says draw a matrix of scatter plots. It's probably easier just to show you guys. So what this does, to just kind of understand what's happening, we're calling pandas.concat, which essentially concatenates a bunch of series. So concatenates panda objects along a particular axis. So in this case, we have 3 series that we want to concatenate, and we're concatenating them by the axis 1, which is the columns. So this gives us a new data frame where each of the columns is, instead of open, close, volume, etc., it's Tesla, Ford, and GM. So this is the opening. This data frame tells us what the opening value for each of these 3 stocks are on a specific day. So we've kind of used our old data frames, Tesla stock, Ford stock, and GM stock, to create a new data frame that contains like similar information, but not exactly the same. So we're kind of like manipulating it to look like this. So this one data frame has information about all 3 of the stocks, rather than one data frame containing a lot of information about a single stock. So now when we try to plot it using scatter matrix, this is what it looks like. So this can look a little confusing. Honestly, I was a little bit confused by it at first, but essentially, like, we have each matrix, or each plot corresponds to a combination of stocks. So you can see, like, in the diagonal, we have something that looks kind of like a histogram. So in this top left, you can see that this is like the Tesla row. And then you can also see at the bottom here is like the Tesla column, or like Tesla on the x-axis, Tesla on the y-axis. So the histogram just tells us like the distribution of stock prices for Tesla. You can see here, like, there's a high concentration of relatively low stock prices. And then, as we saw like earlier, there's kind of like a rapid spike, and it shot up, and then it kind of stabilized after that. So you can see there's like a bigger concentration of like points here. And then we saw Ford and GM, their price was relatively more stable. So you can see that the histogram is a little more like evenly spread out. Same with GM. So essentially what we're looking for in these matrices are like, linear correlation, or like some sort of correlation where, like, as one increases, the other one increases as well. That's definitely the most evident with the Ford versus GM graph. And you can see that these are like, I don't know if you can see my mouse, but this middle right matrix and the bottom middle matrix are essentially like reflections of each other. I mean, same with, like, you can see that, like, this, if you draw like a diagonal line, the corresponding scatter plots are just like reflections of each other, which makes sense because you're essentially just flipping the axes from, like, for example, this bottom middle scatter plot is forward on the x-axis, GM on the y, and then this one in the right middle is GM on the x and forward on the y. But the main takeaway is that you can see that it's like linearly increasing, or is like as one increases, the other one is also increasing. So you can see that there's like a pretty clear relationship between the two stocks, which is hard to see as like from, you know, seeing just like these values on its own. But if you plot it visually, you can see that there's like a pretty clear relationship. Um, so yeah, that's the interesting thing about a scatter matrix plot. Um, this is just kind of like a way to quickly plot everything if you want to see any like super obvious relationships, which we have between General Motors and Ford. Yeah, any questions so far? Yeah, I see the questions are being answered by others, so thank you for that. But yeah, there are different functions from the plot module that you can use to construct different types of plots. Cool. Now we have our third part, financial analysis. So here we're kind of just there's like a bit of reading involved in this part. So I'll try my best to condense the information, but feel free to also ignore me and read at your own pace if that's a better way for you to soak in the information. But essentially, the first thing we want to do is calculate something called daily percentage change, which we have a formula for here. So this essentially says that the return at time t is equal to the price at time t divided by the price at time t minus 1, which is essentially the previous day, and all of that minus 1. So this paragraph essentially just says that tells us like the percent gain or loss. Yeah, if you bought the stock on one day and then sold it the next day. Here it says it's not great for predicting future values, but it's helpful in analyzing the volatility because this is kind of like on a day-to-day percentage change. So it doesn't tell us much about the long-term trajectory of the stock. Yeah, and then this says wide distribution implies that the stock is more volatile. So let's use this formula to create a new column in each of the data frames. So I'll just start writing it, but feel free to try that for yourself. I'll try to not think out loud and be quiet so you can switch the tab and attempt that yourself. But yeah. Another hint is you might have already read this, but the instructions suggest using the shift method, which I would recommend using the tooltip for using shift tab. All right, so what I did was essentially implement the formula that was written here. So price at T would be the Tesla stock closing price, and then we'll also take the closing price shifted by 1. So for those of you who want to know what that does, you can either hit Shift Tab to let the Jupyter describe the method. You can also just create a new cell and run that to see what it looks like. So you can see that, or here, it might be better to illustrate it compared to close. But you can see that everything got shifted forward by 1 day. So we have this 28.08, which was on January 3rd, is now 28 is now on January 4th. I guess it should be minus Tesla shift -1. Let's see. Yeah, it can be positive or negative. So I think we should shift it by -1. Let's see. Cool. So this is what the data frame looks like now. We have a new column called returns, which gives us the percent returns using the formula from above. Price at time t divided by price at time t minus 1. So now that we have this new column added, here we want to plot a histogram of each of the company's returns. We can either do them separately or stack them on top of each other. This is, there's 2 cells. So I believe the first one is if we want to plot it separately. Second one, I just left the code in here. This is just to do it all on one graph, but for exercise, let's just try to plot them separately. You can see that there's a plot.show call for each of the individual plots. So it will show each graph separately. And here's a way to make it a histogram. So we're going to do that for all of them. So now when we run this, turns. Oops. Didn't run it for the other ones. Stock. And then we can also check GM stock ahead. So I actually forgot to add the columns for Ford stock and GM stock, but now that we have that added, these plots should appear. So we can see that based on like the range of the x-axis. So for Tesla, we have between -0.2 and +0.2, while Ford and GM are like between -0.08, -0.06 to +0.08 or +0.06. We can see that Tesla seems to be the most volatile, which lines up with kind of the graph that we saw at the beginning when we were plotting the opening price for each of the stocks. A better way to visualize it if we overlay all the graphs into the same plot. So that's what this does. We can see that we're calling plot like we usually do. We're setting kind equal to histogram, bins equal to 50. That's just like, so I think that's the number of bins. You can see here somewhere. I have skipped over it. But there should be like a doc string somewhere for bins. These kinds of functions are really long, so I'm not gonna find it, but feel free to look for it yourself. But I believe this is just the number of bins that we use in our histogram. Labels the specific plot that we're plotting, and then alpha is actually this one you can also find here, but it's kind of like the transparency for transparency level for the plot. Here we did not capitalize returns. That might be why that's happening. But yeah, this is the plots overlaid. So what might have looked similar with these graphs, because the x-axis range is like shifting according to the distribution of the data. Here we can see them all overlaid, and you can see that the blue Tesla histogram is kind of like way wider than Ford and GM's. So that allows us to conclude that the Tesla stock is more volatile than the other two. And then there's one more matplotlib usage that we can do, which is box plots. So this just allows us to compare the returns. Again, you might have to capitalize the returns index value, but this is what this would look like. So you can see, like, I'm not sure if how familiar people are with box plots. I certainly am, like, rarely see these around, but I'm also not in like statistics or data science. But from here, you can see that like the range of values for each of these for Tesla is a lot wider than Ford and GM. So I believe it's just like centered along the mean, or oh, this might be like, yeah, something like the mean or like the standard deviation 0, and then this is just like how far it deviates from that. So you can see that the box plots for Ford and GM are a lot narrower, which is an indicator that it's less volatile. But yeah, those are a bunch of different kinds of graphs we can create with matplotlib using the same data that we have. And it helps us visualize like certain attributes of the stocks. So now we want to create another scatter matrix. Here we can do one to see the correlation between each of the stocks' daily returns. So this will again tell us how related the car companies are. Yeah, and a question that they asked is Tesla being treated more as a tech company rather than a car company by the market? So a trick here is we've already created a concatenated data frame called box data frame that concatenates all of the return columns for each of the stocks that we have. So going back to when we created the last scatter matrix, we can see that we did a similar thing where we concatenated the open price for all of the stocks into one data frame. So we'll actually use this box data frame that we created. So we can just call it scatter matrix box data frame, and then we can copy over the attributes that we used here. So figure size. Here we go. Figure size, and then we used 50 bins for these returns. So let's just stick to 50 bins. So this is for the histogram along the diagonal, and this is what that looks like. So these histograms are what we have for what we had generated earlier. So it should be the same because we're using the same number of bins. And then the remaining like scatter plots are relationships between the stocks. So this would be Tesla and Ford, and this would be Tesla and GM. Again, we can see like that correlation between Ford and GM as they're like, you can see like as one increases, the other increases as well. Whereas for the other two, it's less obvious. So Tesla doesn't seem to have as strong of a relationship with Ford and GM as Ford and GM do. Here we see that Ford and GM do have a possible relationship. So if we just want to see one of these plots more closely, we can actually directly plot it using plot.scatter. And again, we have to use our positive return or our capitalized returns because that's what I named it. And this is kind of just like a close-up of the Ford GM graph that we have here. So you can see they resemble each other pretty closely. But this is just like a closer version of it. So we can see more clearly that there's like this positive correlation between the two. Now, lastly, we have cumulative daily returns. So now we can see which stock was the most wide-ranging in daily returns, which is Tesla. But with daily cumulative returns, we're trying to answer like a different question, which is how much would, if $1 of investment at the start of like, say, 2012 or wherever, how much would that turn into if you chose like another date? So we can see how our money would have grown if we had invested in this stock. So this is different from the daily returns because it gives us like the long-term returns. So I guess some examples here. Let's say there's a stock ABC that's being actively traded. These are the following prices for the dates. Daily return tells us how much we make from day to day. So when it goes from 10 to 15, that's a 50% return. 15 to 20 is a 33% return, and then 20 to 25 is a 20% return. So this is what we were calculating earlier, but cumulative return gives us the return from day one. So going from 10 to 25, our cumulative return is 250% across that amount of time. So we have a different formula for cumulative return. We have I of I, which is investment at, I guess, time I, is equal to 1 plus our percent returns times our previous investment at t minus 1. I think this, yeah. So that's the formula that we'll be using. And then here we see that Panda has a function actually that makes that a lot easier to calculate called cumprod. So if we want to look at what the docstring looks like, we'll say, let's see, panda.series cumprod. So it returns a cumulative product over a data frame or a series axis. And then it returns a data frame or series of the same size containing the cumulative product. So an example would be, let's see, this docstring. So if we have a series that goes 2, not a number, 5, -1, 0, cumulative product goes from 2, not a number, 10, so 2 times 5, -10, which is times -1, and then 0 or -0, which is that value times 0. So it just continuously multiplies all of the values and then assigns it to that index. So we're going to be using this to construct our new column. So let's say Tesla stock cumulative return is equal to 1 plus, so they have parentheses, 1 plus Tesla stock returns prime. And then let's see what that looks like. So we can see that the cumulative return value is calculated here. So the next thing we're going to do is, So next thing we're going to do is just do the same thing with Ford. Cumulative return. And then GM stock. So now we have this column added to each of our data frames. And then let's see if we can plot it. So we'll do Tesla stock. So now we can plot the cumulative returns. I believe I may have swapped it. Yeah, I was looking at my returns, I think. It is here. Let's rewrite this. It's wrong. So I made a mistake here. It should be shift +1 because we're multiplying our current value by the previous day's value. So we're actually shifting all the columns forward because that makes each of them multiply by the previous. So I think that will fix this. So we regenerate this data frame. So now the cumulative return is, so this looks a little more accurate. So you can see that pretty similar to our initial graph of how Tesla stock has changed. I guess cumulative return would look pretty similar. So this is what that looks like. Basically, if we invested, I guess this is just the percentage change. So you can see the y-axis is different from what it was in our first graph, but it follows a very similar pattern because percentage change is just relative, a relative version of how much that stock has changed. So this just tells us if we invested here, we would have made, I don't know if that's accurate actually. What is this? I guess it goes from 50 to 250. So maybe this number should be different. Let's see. We can reverse it. Yeah, I'm not going to do live debugging, but you get the idea. Uh, we can graph our cumulative returns. We can create new columns and visualize those using matplotlib. So this is kind of just like uh, a short project that lets us see how we can use all of these libraries together. Um, so yeah, are there any questions?
Hey Chris, I have a question. With Jupyter Notebook, I think there's a way you can knit them into like an HTML file and like
Mhm.
post them or something. And so how would you do that?
Yeah, that's a good question. I believe we can do that in file. So if you're using Jupyter, hopefully the UI looks similar enough to what I'm sharing. But if you hit file at the top left,
Hmm.
there is an
Oh, okay.
option that says save and export notebook, and then you
Hmm.
can export it as HTML. So that downloads like a file for me, and then when I open that, this is what I see,
Go, okay.
like an
If
HTML.
you're saving it as the HTML, your original .ipyn file would still be there, right? I mean, it would
Yep,
create a separate file.
it creates a copy. Yeah.
Okay. And then there's also this file called the Markdown file. How's that
Mhm.
different from HTML?
Markdown, I believe, is just like a different format for like displaying, um, I guess, like displaying something. So HTML is, um, I guess, like the web-based version. Markdown is just something that it's like a specific language. So like, if you, I believe, if you export as Markdown, it should show like should give you like actual like a text file that looks like code. So this eventually gets translated into something that's like more like pleasant to look at. Um, I guess like so as an example, like what I'm sharing right now, this is an HTML file. I can open it like directly on my browser. Whereas Markdown, I would need to like interpret that uh, into something to make it look the same. Um, but uh, I guess it's probably useful because like certain, I guess like web development or like um, honestly just like regular like code documentation, a lot of it is written in Markdown. So there are ways to display it in other spots. Like for example, if you're like creating a website or something, and you want to show off your Jupyter notebook, you can write a portion in Markdown, and then it would like get interpreted and display um, display whatever we're seeing here essentially, just like in a different way. HTML is just like a direct file, which I guess you could also embed into your web page, but just like different approaches for displaying your Jupyter notebook.
Um, and then one other question. Okay, like you've generated several like pictures, like graphs, right?
Mhm.
If I want to like download specifically those graphs and then embed them into other document, is there like an easy way to do that?
Yeah, I'm wondering if you can just like directly download them, but when I hit download for Markdown at least, it gave me like a zip folder with like the Markdown um, text file in the folder as along with all of the images that are associated with the notebook.
Um,
So
and so it actually saved each image separately?
yeah,
Huh. Oh, let me try that.
I'm sure there's other ways to download it as well, but that did work, which I just found out because I hit download or export as Markdown.
Oh, you're right. It did like import each image as like a PNG file.
Hmm.
Pretty cool. Okay.
Yeah, that is cool.
Okay.
This is kind of a back to the basics question, but at the very beginning, we imported both NumPy and pandas.
Hmm.
And I was, and if I remember correctly, Pandas sort of builds on NumPy, and I was trying to just like not include NumPy and like
Yeah,
comment it out. Is it just good practice to import both? Um,
that's a really good question. So you're right. I think like we didn't actually end up using any NumPy here, just because Pandas is essentially like not exactly an extension of NumPy, but it uses a lot of similar principles. And often there are some NumPy functions that are useful that Pandas doesn't have. So um, I would say, yeah, it's maybe just good practice to import NumPy. It doesn't necessarily hurt to import it, but you're
I guess
completely right that like it would be totally fine if we didn't import this because we
I
did
guess I
use
guess you'd figure it out when you needed NumPy, when you ran
exactly
across something, and then you go back and you
exactly.
fix it. So,
Yeah, yeah,
okay.
great
This
question.
this was really powerful. Like this really was a fabulous example to bring everything together and really show the power of
Mhm.
Jupyter
Yeah,
specifically to show you the plots and give you the fast feedback. This is like mind-blowingly useful. So thank you.
yeah, of course. I'm glad you found it useful.
And I love the box plots. Yes.
Yes, they are fun. Cool. Any other questions?
Well, so I guess if there's no other questions, we could give Chris and everyone else about half an hour back. So I think this is the last talk that Chris is gonna like give. So, thank you very much, Chris. I know you're super, super busy, so appreciate it. Um and yeah, so thank you so much for doing this. Oh.
Yeah, of course. I'm happy to share what I know. Hopefully, people found it helpful to some degree. And thanks everyone for joining and listening to me ramble.
Well, I mean, I've got no stake in the game, but I'm sure like whoever is actually organizing code in place, okay, when the section leader application comes out next week, no, not next week, next year, okay, they would love to have you and your Berkeley friends sign up because they're always looking for like, experienced, good section leaders. And so, you should help them spread the word.
For sure.
Okay. All right. Well, I'm going to stop the recording. If anyone have any other questions, feel free to like type them in the chat or something.